So I was tasked with um, coming up with a way to take some input data and find out what the maximum difference was for a boring at 1 foot intervals that started at a ½ foot below ground surface. So our original input data looked like this. There's a lot of different sensors on here. I took the ones that mattered to us for this particular effort, that being detector 3 min and detector 3 max. And I think what we were doing before is we were manually calculating the difference here, and then inside of an Excel, starting at a ½ foot down, going down, taking the max, okay, going to the next interval, and then taking the max of that to produce an output file that looked essentially like this for each boring. So this is for one boring, and you can see that in addition to calculating the maximum difference at each ½ foot interval, we then wanted to convert the depth below ground surface to actual elevations. So given that data, I boiled down an input file for one particular well, and I narrowed it down to essentially those same data, the depth interval and feet below ground surface, detector min, detector max. This actually doesn't need to be here because I'll explain why, but I have it here so that we can check. And I've gone ahead and added the XY location, the ground elevation, and the location ID for this well. So this is what an input file could look like. I then scripted out something in Python that really automates this so that we don't have to spend time manually doing some gymnastics inside of Excel. So what this script is going to do is it will take this input file, which is really just a mirror image of what was provided originally, and then it's just going to output a file. So I'll go ahead and run it, and it gives us a little bit of information. It lets us know that it processed 63 1-foot intervals for this particular monitoring well, and you can see the output location of this is this temp location. I've called the file junk. We're going to go ahead and open this up. And so here's the output data that it collected. And just to kind of double check ourselves against what was provided, let me go ahead and pull up what we did manually, just so we can be sure. So these numbers should be exactly the same. So here's the subset from the data that was done manually, and here's the one that we have. So again, you can see that we look at the depth intervals here, 114 to 113, same at 305, 839, and if we progress all the way down to the end of the file here, the last one for this one should be 6027, and it is. So we can discuss this. I can show you how to run this Python script, but again, just an example of how we can use Python to really take a lot of the manual edits out of stuff. Maybe this is something that we can build into some future projects where these input files are needed. Okay, so I hope that helps. I'll follow up later. Thank you.